Hi, in this video, I'm going to introduce you to the IPv6 global unicast address. Okay, so the global unicast address, it has the range of 200,2000:3. I'll explain that more in a moment. So commonly, you're going to see the first hextet beginning with a 2 or a 3. It's globally unique and routable. It's a public IP address, similar to public IPv4 addresses. Okay. Now you're going to see throughout books and these videos and my book and video that 2001:DB8 is used. That's actually a address reserved for documentation, education, that sort of thing. Okay, so we don't climb all over somebody's real public IPv6 address. Okay, global unicast addresses are when we start talking about assigning a device an address or getting it from Slack or DHCPv6. We'll be talking more about that later. These are the addresses that we'll be referring to. Okay, so the range, global unicast address range. So it said beginning with a 2 or a 3. That's because the first 3 bits begin with 001. So if we convert that, so first we can see the first hextet, and if we convert that first 4 bits to a hexadecimal digit, it's 0010 or 0011, 2 or a 3. Okay, all right, the parts of a global unicast address. So in IPv4, it's a 32-bit address. We have a network portion and a host portion. And then we typically are going to subnet. And the subnet, we have to borrow bits from the host portion to create our subnet. And in the video, excuse me, where we'll be talking about subnetting IPv4, it's kind of, it can be kind of time consuming and kind of a lot of students kind of pull their hair out at times. And it's really kind of a pain, to be honest with you. But in IPv6, it's much easier. In IPv6, we have an interface ID equivalent to the host portion in IPv4. Excuse me. We have a global routing prefix. This is part of the network portion. This is how our internet service provider sees us. But part of our network portion is a subnet ID. So in this case, let's say we have a /48. The first 48 bits is our global routing prefix, how our service provider sees us. We can then allocate the next 16 bits between the /48 and the /64 for the interface ID. Interface IDs are typically 64 bits. There's a reason for that because we want to use something called SLAC, stateless address auto configuration, for many of our devices. So the host portion, the interface ID, is usually 64 bits. So the space between the global routing prefix, what we get from our provider, and the interface ID will be our subnet ID. In this case, 16 bits. So notice if we have 64-bit interface ID, 18 quintillion devices per subnet. If I have a 16-bit subnet ID, that will give me 65,536 subnets, each one with 18 quintillion devices per subnet. This, by the way, is a very common global routing prefix allocation by service providers. They will typically give most organizations at least a /48, might even get, which leaves them with a 16-bit subnet ID. Could be even more. They might give you a /32 that gives you a 32-bit subnet ID. A lot of IPv6 addresses out there. We don't have to worry about conserving address space. Okay, so let's say we have a /48. Very easy to look at the global routing prefix, subnet ID, interface ID. Okay, and I kind of think of it as using in a /48, the 314 rule. The first 3 hextets is the global routing prefix. this is how our service provider knows us. This is would be the prefix, the network address that our provider sees us as. The subnet ID 1 would be 1 hextet. Okay. And then the rest, the next 4 hextets, is our interface ID. Okay. So that's the 314 rule. Now, the 3 plus the 1, okay, that first 4 hextets is the prefix, the network portion. It includes the global routing prefix and the subnet ID. The last 4 hextets is the interface ID. Okay. So as you can see here, by the way, notice that we have reduced it. We've got rid of the leading 0 there. The leading 0 is here. We replaced these 3 hextets with the double colon. Okay, and we removed, oops, that should be right there. There we go. And we've omitted this leading 0 as well. So this is the compressed format that we learned earlier. All right. Okay, so I hope that gives you an introduction into the global unicast address. We'll be talking more about these and prefix lengths and all kinds of good stuff in upcoming videos.